Good afternoon and welcome to Design Master Training. My name is David Robison, and today we are going to be looking at feeder IDs on one-line diagrams. If you are attending the training live, you can ask questions using the chat box in the Blizz interface. If you're watching the recording, you can call or email with your questions. Our phone number is 866-516-9497, and our email address is support@designmaster.biz. So today we are looking at feeder IDs on the one-line diagram. The feeder IDs are these labels here that indicate the feeder size for each feeder. You can put them in as graphics on the feeder, and then this corresponds to a schedule that you can insert on the drawing. So if we put the feeder schedule here, each row denotes a specific feeder configuration, wire size, number of wires and such. And then there's an ID that typically it has some sort of descriptor in there, the symbol, and then that links back to the feeder IDs here. Now the idea behind the feeder ID is that it's a little bit more of a compact way to label your feeders as opposed to having your feeder sizes on the drawing next to each feeder. The IDs that are used, the actual text that's in that graphic, is completely, it's some level arbitrary. Software doesn't really care what you're using. Typically, you have something that has a little bit of meaning and context for the person looking at the drawing. Typically, it's referring to the ampacity of the feeder, but that's not strictly required. And we'll look at later on some ways to customize that, ways to have the software generate it for you, and the ability to change that. These ID values can also be linked back to Revit if you are one of our Revit users. So after you update your one-line diagram and you have the feeder IDs, then you can go back to Revit. And in Revit, we have, and if you go to a schedule, we have a shared parameter on all of our electrical equipment. It's the DMET feeder ID. If I add that to this schedule, it'll then show up. And when we run our calculate, it'll pull in those feeder IDs from the AutoCAD one-line diagram. And so all of these feeder IDs here correspond to the same feeder IDs over here for the feeder that's feeding that piece of equipment. So if you do want to have those labels showing up in Revit, you can using this shared parameter. And so when they update, they'll get transferred back here. In terms of drafting, if you select the feeder itself, you will get a grip point for the feeder ID, and then you can stretch it and move it along the feeder so you can relocate these to have it, in a good spot so the drawing looks nice and clean. When you run the match command, it will match the location to other feeders. So if I take this one here, and not that you'd want it here, but if we move it up so that it's really close to that, we can then run the match labels and graphics. If I select this feeder and then match this one to it, it will transfer that location. So if you want to line them all up, you can use that to line them up, same as you would with labels. In terms of the graphics, the symbol itself is customizable. And the way you do that is a little bit buried. You need to go to the feeder ID section in our customization. If you're using our AutoCAD-based software, it's DM Electrical Customization Feeder IDs. For our Revit users, it's similar. It's under Customization Feeder IDs again. So a similar spot for both of the programs. And then you have the feeder IDs. You always, for all of our customization, have the customization for the project and then for your master. We'll take a look at the project for this one. There's quite a few options here. I want to look at just the block for the moment. We'll come back and look at these other options a little bit later. To get to the block, you need to press the Select Group command. And then you press Edit Settings. And this finally gets you to the settings for that group. And the block is set for each group. So that's why you kind of have to dig down to get to setting for the block. And then we have here the feeder ID block, and you type in the name of the block, and that's what we will use. If you click Browse, you can go select a different one. If you filter this, do a star, feeder star, it'll pull out just the feeder ID blocks in our customization folder. This is kind of what we have built in by default in our software, and you can customize and add and create your own. We currently are using a hex. If I switch it to this oval, click OK, I've now got my oval set there. Exit out all of these, and when I run the update, it'll swap in that new feeder ID block. And so there's our oval, which happens to be a very large oval. So you probably don't want something that looks exactly like that, but you do have the ability to customize it. I'm going to go ahead and change that because we do not want to have that huge oval while we're doing all of this work. So that's how you can choose different blocks to be used. If you do want to customize that block, you can run the open block command to open up that graphic. Again, this is under customization. In block creation, there is, actually no, below block creation, there's an open block from drawing command. You run that command, select the feeder. It lists all the feeders, all the blocks on the feeder. Select your feeder ID block, click OK. It'll open up that file, and then you can make changes. You can adjust this, stretch it, replace the graphics if you want to have it look like something else. These top, bottom, left, and right attributes are important. You want to set those on the edges of your feeder ID so that our software knows where to connect to the feeder line itself. And so it'll keep the feeder horizontal like this, and then see it using the top and bottom to make a connection, and the left and right here, so it breaks the feeder line behind it nicely. So that's the point of these attributes, is make sure they're in the right spot, and then the ID is where we put the actual ID text. The layer and text style are also controlled in customization. If we look at the layers, in the one-line diagram section, there is the one-line ID, and that's going to control the layer that is used for the block itself, and then one-line, where is it? One-line text will control the feeder ID text inside that feeder ID. So there's actually two different layers being used for those feeder IDs. So I can take this ID layer and let's just change it to a different color. I'll make that magenta, and then I'm going to change my text to be white. So if we change those, we'll now see different colors being used. We change that in the settings in the project. To update the drawing, you need to run the update drawing layers to match project list command. Run that, and it will update the layers. So now we've got the magenta block being used, and all the text for the one-line diagram actually has been changed to white. So we use a consistent text layer for all of the text in the one-line diagram. But now the feeder ID has been changed along with everything else. The text style is just the standard one-line diagram text style. So again, it's going to share the text style with all of the other text in the one-line diagram. But you can change that under styles. So we can come here, and we have a one-line text style that you can change, or you can change the default for everything. And make a text style called one line. I'm actually now going to create a style so we have something match that. I'll create my one-line style, assign a font to it. And now when we run our update one-line diagram, it'll pull in that new text style for us. So that's how you change the text style, both for the feeder ID and for everything else. You can have different graphics for different groups. I meant to show that, so I'm going to go back to that. So if we go back to the feeder IDs, we have a single group right now. You can actually have multiple groups. Where I see this most is people have different groups and different symbols being used for copper versus aluminum. feeders, for example. So we could rename this. This is going to be our copper group. And now I'm going to make an aluminum. So now we have these two different groups. I'm going to take the aluminum and I'm going to give it a different feeder ID block. And now when we created that one, we don't have any feeder IDs in that group yet. If I click Select Group, I can go to the copper, and I'm going to take, actually I think these are all going to be copper. So moving them, any of them over to the aluminum is a little bit nonsensical. But I will take a couple and I will move it to the aluminum. I'll take that 150 and I'm going to take my 400 as well and move it over to the aluminum group. And so this 400 here should now use a different wire callout after we run our update, our feeder ID callout. So now we've got the hexagon here being used for this feeder ID and the oval for this feeder ID. So if you need different feeder ID blocks, create different groups, assign the feeder IDs to the appropriate group, and it will use the appropriate graphic for it. The feeder IDs, the actual text in there, is created when it's needed. And there's quite a few different options for that, so we're going to go ahead and walk through all of those so you can see the different ways you can create those feeder IDs. This is all going to be in the options in your customization. So for Design Master Electrical, it's customization options. Same for our Revit software. And in both cases, in the one-line diagram section, down toward the bottom, we have a number of settings related to feeder IDs. The format, whether they are automatically created or not, whether after they're created they're copied to the master, and then if they exist in the master, if they're copied to the project automatically. So we will walk through all of those and show you what each of these different settings do. First thing I'm going to do is I'm going to take this automatically create feeder IDs. I'm going to change it from yes to no so that we actually can see what's happening when they are created. And we're going to leave the feeder ID as short for the moment. The other options are long, size plus a letter, and then sequential. So we'll leave it at short. Click OK. I am going to go to my feeder IDs. And we already have all of the feeder IDs created, so it doesn't need to create a new feeder ID. So what I'm actually going to do is I'm going to run the delete multiple, and I'm going to get rid of those two from that group, and I'm going to get rid of all of them from the copper group as well. So now our feeder ID list is totally empty, and so when it goes to do an update, it's going to see that it needs to create these IDs. And so when you do the update, it says, okay, here's a feeder callout that does not have an ID. We turned off the automatic generation, so now it's kind of a manual process. And so what it says is, okay, here's the feeder callout. This is the ampacity. And then based upon the feeder format that we selected, this is the recommended ID for it. So it's 100, and then the group, if you want to put it in the aluminum or the copper group. And so it's always going to put them in the first group sorted alphabetically. So if you need to get that first group at top, you might need to adjust the name a little bit to get it to sort nicely. So since it doesn't exist, and we are asking it to create it manually, it basically prompts you, and this is where you could put in a different ID if you wanted to. So if you don't like default IDs, this is one way to get them created with different IDs. You can click OK. And then it sees, okay, here's another feeder that it needs to name, and asks you, okay, for this feeder callout, what do you want the feeder ID to be, and then what group do you want it to be in. It will continue doing that for all of the feeder IDs. So this takes a little bit of time if you're doing this manually at the beginning of a project. Once they're created, they'll be created once, and then it's not going to prompt you anymore. That's also why we have this checkbox for the automatically create feeder IDs. So if you're happy with our default formats, you check that, and then it just creates them without prompting you. And that's the same option that's in there in the options dialog, the create automatically. So this just toggles that same option on or off. There's also an option to create feeder ID in the master schedule. So the idea behind that is that if you want to have a consistent set of feeder IDs across all projects, you can, when you're working in a project, populate the master schedule at the same time so that other projects will use those same values. So you set up your master correctly, and then all of your other projects are going to use that. So I'm going to go ahead and check this to create the feeder ID in the master schedule. I'm going to automatically create the feeder IDs in the future, so it'll just finish it up. Click OK. It goes through, it creates all those IDs. All of them that create puts in the master schedule. If we go to customization, feeder IDs, if we look master list now, it also has the feeder IDs that were created during that process. Other option is the transfer feeder IDs from master schedule. And so this is if you have your master schedule set up and you like the IDs that are in there, when it goes to create one, the first thing it'll check, if this is set to yes, is it will actually look at the master, see if there's an ID that it can use from there. If there is, it copies it to your project for you and uses it, doesn't even prompt you, even if this is set to no, where you're manually creating your feeder ID. So if it finds one that it can use, it will use it instead. So I'm going to leave that at yes, this one at no, click OK. And I'm going to go into my project feeder IDs, and we will get rid of all of those. I'll also go ahead and go to the master. And if we rename some of these, I'm just going to put an M in front, indicate that this was copied from the master, so that when we see that it's copied, we'll see that we're actually pulling the master value. So we've created a couple, so they have the M in front. So now when we run our update, software will see that, okay, I don't have these feeder IDs, it's set to check the master, it looked in the master, it found them, copied them from the master to the project. And so now the project has those feeder IDs created. So it created them for us. You can see it created the ones with the M's. So it's actually copying from the master. It's not just generating them like it normally was doing. It was seeing the master had a value. And it's then obviously using those on the one-line diagram in the feeder schedule, transferring it back to Revit. We have a couple different formats that we can use. So far we've been looking at the short format. And so what that'll do is on a three-phase feeder, it just uses the ampacity as the ID. For a two-phase, single-phase feeder, it does a /2. And if it has two of the same ampacity with different ground sizes or something, which happens if you got a service versus an equipment ground, it just does a .A, .B, .C to just indicate that those are different configurations. You might want to change those depending on how you want to denote the different feeder sizes based upon that different ground wire. So the 100 amp here is an example of that. And to change it now, I'm going to take transfer from master. I'm going to set that to no. I'll copy the master. I'm also going to set that to no. So now we're disconnected from the master basically for the rest of this. And I'm going to change it from short to long. And what this will do is the long feeder ID creates a feeder ID that's basically longer. So the short ones are kind of intended to be as compact as possible. The long ones are intended to include more information on them. I will go to my feeder IDs and clear all of those out. So when you change your format, it's simplest to just use the delete multiple once again to erase them all, run the update, and that will give the software a chance to recreate them. When we do that, you can see that now instead of just using a 100 for the ID, it's a 100/3, saying it's a three-phase feeder, and then N and G, saying there's a neutral and a ground wire on it. So again, a longer call out. If you combine your neutral and your ground wires, you'll get a /4 in this case, saying that just that there's 4 wires. If we click OK, 300's the same. Eventually, yeah, so now we have the 100 amp, and then we have to have the different ground wire size. So it's a -A at the end to indicate that it's a different size wire. Now go ahead and automatically create all of those. It goes through. So these are the feeder IDs that are being used now. That's the difference between the short and the long. The long is intended to have a little more information so that when you look at the ID, you have a little bit more of an idea as to what is happening with that feeder without having to go back to the feeder schedule. It's just a preference on your part as to what you like to have for your feeder IDs. And from there, we can go to the size plus letter. Okay, and what this will do is that each configuration of wires just gets a different letter after it. So rather than doing the /VNG or something that the long feeder ID is doing, it just does an ABC, and so all of your three-phase feeders will have like a C after them, and all your single-phase wire and single-phase three-wire will have a consistent letter after them with the ampacity also listed. So I'll delete all of our current feeder IDs there, run our update, and you'll see that it created all of them for us. And all of these feeders have to be very similar. They've all got neutrals, they've all got grounds, so they're all getting that J designation. If they were single phase or they had different numbers of wires, neutrals without neutrals, you would get different labels there. The final option is the sequential. And what this does is it will just use numbers from 1 to however many feeder IDs that you have and just label them for you that way. Well, it just did 1 through 8, just numbers increasing in order. The one thing to note about this is that if you need to add another feeder ID, what ends up happening is it's going to go at the bottom even if the ampacity is going to be out of order. To demonstrate that, let's go ahead and change one of these. This is based on my Revit project, so I'll go back to my Revit project here. We'll take this panel and we'll change it to 200. I have a 200? I don't. Okay, so I made a 200 amp feeder. Export that out to our AutoCAD project. So now it needs to add a 200 amp feeder. So since these feeders already exist, it's not going to try and rearrange the IDs. The IDs are static such that if you publish this, you don't want to have to constantly have your IDs updating on you because that would require a lot of revision clouding for things that didn't actually change. So we run our update, and what this will show you is that added that new ID. There was a 9 in there somewhere that it skipped over. It says, okay, here's that number 10. It's the 200 amp feeder. So it was added, and we put it at the bottom. So that if you had published a set of drawings and then you needed to make a revision and you added this 200 amp feeder, it's not going to require you to do a revision bubble around all of your feeder IDs saying that they changed just because you put a new one in. You just bubbled it. Okay, this one changed, and this is where it is on the drawing. So it makes it a little easier when you're doing changes if you have the sequential and not have it reorder. If you do want it to reorder, what you want to do is go into the feeder IDs under customization, and you can use delete multiple. And here, if you want to reorder them all, you can erase them all, and then it'll start over from the beginning. Alternatively, if you had published a set that was through a certain number, and then kind of the stuff at the bottom was still kind of mixed up, you could delete the ones that had been added since you had done your last published set. Delete just those ones, and then it will recreate those ones for you. So we deleted 8, 9, and 10, and so then it'll recreate those, but in order based upon ampacity. So if we run our update, you'll see that it needs to recreate those, and so it rearranged them so the 200 amp one's listed first. So that's what's happening with the sequential. And the feeder ID format you choose is strictly a preference on your part as to what you like to use. Those 4 types seem to cover most people's options based upon the one-line diagrams we had. And so we're hoping that you can find one there that works pretty well. And then again, if you really, really want to have something different, the suggestion would be to create them ahead of time in your master and have them fill in. And to have them created automatically, in the feeder IDs, we have the Create Feeder ID command. This is only in the project, so you can't do it at the master level. You do this in a project, and then in the master, basically it'll create it in the master for you if you have that box checked. But you create it at project level. But you can create your feeder IDs. And when you run Create Feeder IDs, it only works if you're actually using a feeder ID format. It doesn't work for the sequential. I'll change it to short, okay. And then it gives you this dialog box and it says, okay, what ampacities do you want to create the feeder IDs for you? And you can create it for as many or as few as you want. So say we just want to fill in some of our larger feeder sizes here and just the copper ones. The number of conductors that we want to create the feeder IDs, if we want to do it for all types of IDs or just the single phase or the 3-phase. If we want to create the feeder IDs for neutrals, with or without neutrals, with or without grounds. You check all those settings as to which ones you want to do, whether you're going to create it automatically or not. And you click Create, and it'll go through and create all of those IDs for you. So we now have a bunch of IDs that are created. They're not all being used in the project, but they're created so this way we could put them in the master, and then in the master will then transfer them to the projects as needed. So that's an easy way to populate your master with multiple IDs. And you can see that all of those options, you end up with a bunch of IDs. If we look at just the 175s here, just each of the different configurations. Here's a single phase, single wire with neutral, and so on from there. As you've got the single phase with and without a neutral, with the different ground sizes, a single phase 2-wire, no neutral. That's those here. So it creates lots of them, and that's the intention of that command. Looking at the rest of this, you'll notice that we also list the conductor wire size, the number of wires, the neutral wire sizes. That's all for scheduling display purposes in AutoCAD. In terms of what is it like the true stuff, the important stuff, feeder ID is obviously important because that's shown on the one line. The feeder callout's important because that's the actual label of the wire that we're going to use. So you got to make sure that those two match. And then the ampacity is used because that's going to be used for some sorting purposes. So those 3 are the actual true description of the feeder ID. The rest of these are labeling, and the software tries to set it right, and most of the time it does, but you can get a little out of sync. In fact, you can come and change it such that this 2-watt here can no longer match what's in your feeder callout. And you obviously don't want that to happen, so if you just need to change it and make sure that you leave them as they are. But we have them there so that if they do get out of sync, you can change them back. And then these can be used in the feeder schedule if you want separate columns calling out the different items, as opposed to having just a single column with the construction of that whole feeder. So looking at the feeder schedule here, when you run the insert feeder schedule command, you also have this edit columns button. Press that. Here's where you can add columns, those pieces of information. So we could include all of those and in fact turn off this instead. And you can rearrange them and relabel them. So if you want to have a schedule that lists these separate items in separate columns, you can do it. And the way we fill those in is based upon what's set in that feeder ID. If you're not using the separate columns, what those values are has no other bearing on anything else, so you can completely ignore it and never worry about whether they're set right or what they're set to. It's only if you're using the separate columns in the schedule those values are ever actually used. That is everything we have for feeder IDs. So if you have any questions about what we just covered or anything else related to one-line diagrams, feel free to type them into the chat box if you're watching this on the delay, and ask questions by calling us at 866-516-9497 or sending an email to support@designmaster.biz. All right, so here's a question that we get quite frequently. And the question is, how do I create a motor control center in a one-line diagram? So the first step is that you have to create a motor control center either in Revit or in AutoCAD. In Revit, you create it as a piece of electrical equipment. In AutoCAD, you create it using our software. I'm going to do this actually in our AutoCAD project. So it's a little simpler for me to create the items here. So I'm going to start by creating a motor control center. So you have the piece of equipment. I'm going to connect it so that it's connected to the rest of our stuff. And so now it's a piece of equipment in the one-line diagram. And it's going to insert just like everything else. So if I insert a one-line diagram, that MCC is just going to be seen. It's set up to use the same graphics as the panel, so it's just inserted as a panel by default. So typically what you want to do is you want to draw it out with the different little starter connections. And the way to do that is to actually create a custom block that has those for you. So we would just kind of come over here, and probably you already have a block that you're using, but if you don't, you can do a little drafting and create one. So you just draft it however you want it to look. There's our motor control center. And then you need to turn that into a one-line diagram block. One-line diagram block from entities is there. You choose all the settings. You set all of these as appropriate here. We're going to connect from above. We'll have the downstream connections going off to the right. They're going to have to kind of redraft all of those once you get it connected anyway. I'm going to create just in the project so I don't fill up my master. The upstream connection point, we'll have it connect here to the middle. On the downstream, it's going to come out the right side. And then for the insertion point, I'll use the midpoint of it. Now we have that block as an option for the one-line diagram. And I can come here, change my graphics, and choose to use that motor control center. So there, now we've got that as a graphic. And so now it looks like a motor control center. And then the next thing you need to do is actually get the motors connected to it and included. That's a little different in our AutoCAD versus our Revit software. In AutoCAD, you'll need to create the motors using our Create Equipment command. So I'll create a motor. I'm going to create these in the database. And actually, you need to make sure that in the one-line diagram settings, you have Show on One-Line Diagram Set. You also have an option here to set your graphic. And I forgot we don't actually have a motor connection included by default. So you'll want to draw a little motor, create a block from that. We'll use this equipment connection instead. And I'll create a couple of these in the database. And then we will connect those pieces of equipment to that motor control center. And since they're in the database, I have to use the Circuit Equipment in Database command. I've got my motors here. I'm going to connect to my motor control center. So now we have the 4 motors connected to the motor control center. They're set to be displayed on the one-line diagram. So if I run the generate, select the motor control center, it'll put them all on the drawing for us. And then at this point, we need to kind of do some drafting to get the feeders set up right. You could also, and this might work better, insert the motors manually. So insert one, and then you could insert the other, going along like this, probably laying them out more nicely than I am. You can also, and this is particularly if you want to adjust the labels, you could adjust the labels, the call out in the circuit here. So that's how you do the motors in AutoCAD. In one-line diagram, in Revit, it's very similar. However, to specify the pieces of equipment, you have to go to the piece of equipment either in the family or in the instance, run the edit command, and do the show on one-line diagram, set this to yes. That way it'll actually show up on the one-line diagram. Otherwise, it's not going to be displayed. That's how you get it to show up there. And when you export, that will be included in the model that is drafted in AutoCAD. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.